It is time for the Naked Scientist. He's now connected. So we welcome Dr. Chris Smith, of course, consultant virologist at Addenbrooke's Hospital, Cambridge. It's good to have you back.
Morning, Clarence.
So let me go to a question that we have here. Does alopecia affect all people of the world in the same way? Does it occur less amongst Chinese, for example? A question from Andre.
Hi, Andre. Alopecia means loss of hair, and this can occur in small defined patches on the body. If you have a patch of hair loss on your head, this may be alopecia areata. This means it stopped in one particular place. On the other hand, you may have alopecia totalis, which means all over your body. The processes are similar in the sense that for some reason the immune system in one patch of the body has destroyed the ability of hair follicles there to make hair. And if you don't have hair follicles working, you have no hair. And if that happens all over your body, you have no body hair. If it happens in just one patch, you'll have no hair in that one patch. Now, people all over the world do differ in terms of their susceptibility to autoimmune conditions because some of them are linked genetically. There are certain genes that code for how the immune system works that make some people more prone to getting certain autoimmune diseases, and there are therefore those associations, and some of those genes are more common in some populations than others. On the other hand, we are all human beings, we're all the same species, and we are all very, very similar. Therefore, we can all get the same diseases one way or another. So it's not true to say that certain populations never get certain diseases. That would be untrue, but there are certainly some conditions that are more common in some parts of the world. And as far as alopecia goes, I'm pretty sure that we're all susceptible to one extent or another, but there are certain people, certain groups that are more susceptible within those populations. So I think you'll still find people in certain areas of the world who will get this condition, but they're going to be more defined in some populations than others. And this is probably what we call a founder effect. It's probably that certain groups, because of the way humans migrated and then settled and inhabited and bred in certain areas before we became the hugely mobile population we are today, and that led to certain genes being concentrated among certain groups, certain cultures, certain geographies, which then take along a higher risk of certain diseases with them.
Let's go to Anne in Thornton. Welcome, Anne. Great to have you with us.
Dr. Smith, eczema. I know of somebody who had eczema for probably over 30 years. It just escalated over the years. And later she developed shingles. This person actually passed away. I want to know, why does eczema not leave the body? Why does the person not heal? What is it that causes eczema to actually escalate in a person's body?
Morning. Eczema is very common, and the other name for eczema is acute dermatitis, but it's actually a chronic condition. And what is happening with eczema is that you have some particular allergen, something that you react to, and you have in your skin cells rammed with histamine called mast cells, covered in antibodies called IgE antibodies that have been programmed to respond to this particular thing you're allergic to. Something causes the skin to be damaged in a particular area, and you scratch at it. Often that's an irritant. This opens up small holes in the skin, allowing the allergen into the skin, where it sees those mast cells, because the IgE antibodies grab the allergen and then tell the cell to activate. The mast cell discharges all this histamine into the skin, and that makes an intense itch. So what do? You scratch more. If you scratch more, you break down the skin more, which allows more of the allergen in, which makes more histamine, and it becomes a relentless cycle called the itch-scratch cycle. And the more this happens, the worse it gets. And because it feels nice to scratch and an itch is incredibly irritating, literally as well as metaphorically, we do it more. And breaking that cycle is very, very difficult because you can't reprogram the immune system easily. So therefore, you remain allergic to whatever the thing is. And if you're allergic to something that's ubiquitous in your environment, it might be something in the clothing you're wearing, like a chemical lanolin on wool, for example. It can be other things, just substances in the environment that you are allergic to. if they're everywhere, it's very hard to get away from them. Therefore, you will always have that immune response, and therefore you will always have that allergy. And just as we were saying, there are some people who are in certain populations in some parts of the world that have genetic predispositions to certain conditions. Allergies and acute dermatitis are also linked genetically, and they tend to run in families. So if you have a number of family members, close first-degree relatives, who have asthma and also eczema, they often go hand in hand as the same similar allergic phenomena. And this is why, if you've got this when you're young, you'll probably have it for the long term, although that's not true in everyone's case. In some people's cases, it goes away with age. And also, new allergies can crop up at any age. And I was talking to an allergy specialist at Addenbrooke's Hospital where I work called Pamela Ewan, very famous, and she's even cured people of peanut allergy. And she said to me, we get some 70-year-olds come to our clinic with new onsets of allergies, so it can happen at any age.
Shadley has a question. Why are people more allergic to seafoods?
I don't think there's evidence that they're more allergic to seafoods. You can be allergic to pretty much anything, because the way an allergy works is that there are particles, proteins, which are in a thing that you're going to react to. And in a person who has an allergy, you have made an immune response against that protein. Now, most of us, this doesn't happen because the immune system can tell the difference between friend and foe very well. But for some reason, in some people, possibly for reasons of genetics, but also prior infection can also sensitize you to certain things. As a result, you start to make an inappropriate immune response against things in your environment. Seafoods can provoke this in some people, but certainly not in everybody. And really common other allergies are, of course, hay fever, which is an allergy to the proteins in pollens, house dust mites, which are the things that fill up your pillows and your bedding, and the poop of a house dust mite is very rich in an allergen that causes asthma in susceptible people. So seafood is just one thing that people can be allergic to, but there are many. And it's amazing, really, that we're not more allergic to more things more often. But the evidence is that allergies are becoming more common in general. We don't know exactly why, but we suspect and invoke something called the hygiene hypothesis to explain this, which is the argument is that we're living a life which is far too sterile and far too clean. We're not challenging our immune systems in the normal way that we've evolved over millions of years to have it challenged. We live in environments that are extremely sterile with very specific populations of microbes that are not the ones we would have over evolutionary times have run into so much. And perhaps this is reprogramming our immune system to go down a path towards a greater risk of allergy in some people. And that's why this is happening. And for some, it just happens to be seafoods.
Fascinating. A couple of voice notes in, so let's go there. We're going to go to Matt's one first. Joe?
Hi, Clarence. Question for Dr. Chris. At what point do two things become different species? Like, why is a Chihuahua and a Great Dane the same species, but a lion and a tiger are two different species? And then maybe also, why, if you breed two different species, is the offspring infertile? Like a donkey and a horse makes a mule, but a mule is always infertile. Thanks. This is Matt from Somerset West.
Hi, Matt. Well, dogs are interesting, aren't they? I mean, when you look at a dog and you look at all the different breeds and the different crossbreeds and you think, well, they look so different. They must be a different species because I've seen a bee and a wasp look more similar than some dogs do. But dogs are all the same species. All dogs are pretty much, if you take size out of the equation, because that can be a challenge, they ought to be capable of interbreeding and they should all be fertile amongst themselves. And the evidence is, there was a paper on this a week or so ago actually, looking at the origins of different dog breeds, and it seems that dogs began to diversify as far away as 10,000 years ago. We first domesticated dogs probably 15,000 years ago or so, probably as humans began to live in settlements more, farm more, and therefore the animals, which they're canids, aren't they? So they're sort of wolf family. They would have had encroachment onto human settlements, and there would have been an adaptation of the dogs to cohabit with humans. We then quite quickly began to select for dogs with certain traits that were good at doing certain things. Big dogs that are vicious as guard dogs. Small dogs with good noses that can help us track down food sources or people who've gone missing. And so we began to select for dogs that had characteristics, but that doesn't make them a different species. In the same way that if you look across humans across the world. If I go to the far north, I will find people who are Inuit peoples that look very, very different than people who live in my country. And people who live in South America look different again. Across the African continent, 54 different countries. There are different looks to the way people are in those countries, wherever they are, because geography has selected for characteristics and certain genes that give you those characteristics, but we're all still the same species. So let's not muddle up the difference in phenotype, which is what we look like, from differences that are caused by being a totally different species. And the definition of a species is it should be something that you can't breed outside that species. So two animals of the same species can breed, two animals between species shouldn't be able to breed, but there are some exceptions, and you highlight one of them. Things like a horse and a donkey can produce mules. Now, the reason that you end up with infertile offspring under those circumstances is that while it works in one direction, it can lead to an incorrect number of chromosomes that mean that when you try to make gametes, which are the eggs and sperm from the resulting hybrid animal, you get a number that's not right, so that when it tries to have babies, the wrong number of chromosomes is passed on, and therefore the offspring are infertile.
Good day, Dr. Chris. Going grey, okay? Now specifically talking about the beard. Why does the left side or the right side go more grey? Why doesn't it go equally grey, left and right? Thanks, Ron from Northern Suburbs.
Hello, Ron. Well, of course, upstream of this question is, well, why does hair go grey at all? And the answer to that is that the natural colour of hair, because it's a protein called keratin, and it's the same protein that your nails, fingers and toe nails, are made of, it's white, has no colour. And when we grow a hair from a hair follicle, which is a little ring of stem cells embedded in the skin, at the base of the hair follicle is a population of cells called melanocytes. Melanocytes are the cells that also give us our skin colour. And when you tan or expose yourself to ultraviolet, they add more melanin and make the skin darker. They make hair darker as well, but unlike the skin, where it's a more reactive phenomenon, they're turned on permanently at the base of the hair, and they impart melanin to the forming hair, which gives it its colour. Different recipes of melanin, prescribed genetically, give different colours, which is why we have different hair colours. Some people have very dark hair, some people have ginger hair, for example. They're all different flavours of and combinations and compositions of these so-called eumelanins, which are the darker melanins, and the pheomelanins, which are the yellow ones. For some reason, as we get older, the melanocytes in hair follicles clap out. Doesn't seem to happen in the skin, we don't know why, but in the hair follicles, the melanocytes eventually stop working. They're not producing any melanin, so as the hair forms, it's a bit like the painter has run out of paint in his tin of paint and can't paint the hair anymore, so the hair comes out uncoloured, white. As it does that, or as it begins to do that, the melanin can sometimes come in fits and starts. It's a bit like when the sprayer's almost running out, your spray can is almost running out, and you get a spurt of colour, then nothing, a spurt of colour, then nothing. So you get salt and pepper hair, you get greyness, not completely white, not the right colour either. And that comes in fits and starts before the hair goes completely white. That's when you've completely lost the ability to make melanin from your melanocytes in your hair follicles. Now, the way in which that's happening is at random. Some hair is going to have melanocytes that work a bit longer and remain active for longer. Others appear to be more vulnerable and will expire sooner. We don't know why that is, but because it's a relatively random process, the greying process generally not symmetrical. Global, yes, with a degree of randomness, but it's not going to be asymmetric. It's going to happen at random. So there are going to be some situations where people do go more grey on one side sooner, but because it's generally happening stochastically at random across all your hairs, you're going to largely see greyness happening at the same sorts of rates everywhere across the body in those similarly populationed hair follicles. So if you've got you can't compare beard with head hair because there's different follicles doing different things and growing at different rates. There's going to be slightly different effects there. But across your beard, you should expect to see roughly the same patterning of greying at the same sort of rate symmetrically because it's a random process.
Okay. Well, now I know why I look the way I look. Zuki, welcome.
Hi, Clarence. Are you?
Lovely, thank you. We are running out of time, so we're squeezing this one in.
Hi, Dr. Chris. Quick question. A person who has mild allergies and has been diagnosed with asthma but is not being treated for it, are they more susceptible to getting bronchitis? And if so, is there any way of making one less susceptible to getting bronchitis?
Hi, Zuki. Well, certainly if you have asthma, asthma is a state of inflammation in the lungs. If you have more inflammation, then if you get infection on top of the inflammation can become worse, and therefore infection can provoke asthma, but asthma can also provoke worse symptoms and longer lingering symptoms of infection. So they can go hand in hand, yes.
Wow, that was a quick answer. And that means we can maybe still ask this question. David wants to know from you, Dr. Smith, what is the color of a zebra, black or white?
I remember I was on this safari in Zimbabwe, and the guide did the classic trick. All these guides do it, don't they? They say you can tell the males because they are black stripes on white, and from the females, which are white stripes on black. And there are tourists who fall for it every single year. Luckily, I wasn't one of them because I sort of said, hang on a minute. But I think he thought he got me for a bit. But don't fall for that one. If you go on safari somewhere or you go to a zoo and someone tries to tell you that, don't fall for that one.
So they are both black and white, I guess that's the answer.
The white hair is the natural colour of the hair. The black is a pigment being added to the hair. So you could say that all animals have white hair with black patches or darker patches, because where they've got colour is where they've added colour, where the natural colour of the hair is white.
And in some places that follicle isn't working.
And that's where the hair has gone grey. That's right.
Okay, not white. Thank you very much for your time. It's appreciated. The Naked Scientist every Friday. It's a huge appointment because of the questions that we get in. And of course, most importantly, his ability to answer them. Diverse at times. Consultant virologist at Addenbrooke's Hospital in Cambridge. The Naked Scientist.